Hey everybody, today we're going to talk about balancing chemical reactions and also what's called conservation of mass. So, conservation of mass is kind of an important concept in chemistry. So, the one thing we need to think about is whenever you do a chemical reaction, at the very least you're dealing with millions of atoms. So, if you take a beaker full of one chemical and a beaker full of another and combine them, that's I don't know, gazillions of atoms being mixed together. So you never really react one atom at a time. So when we write down a reaction, that's kind of like if we're just dealing with like a few molecules. So it's sort of like a representation, even though that happens on a really large scale. But in either situation, the important thing to remember is chemical reactions they don't create or destroy any atoms, but they do rearrange them. So, this is a good thing, an interesting thing to think about. So when you burn a piece of wood, it looks like the wood just kind of goes away. But it doesn't go away. The wood's actually being changed into. So you basically take this piece of wood and you're changing it into sorry, start again. You take the piece of wood, which is made of carbon, hydrogen, and oxygen, and you combine that with oxygen by burning it, and you get. Remember we talked about combustion reactions. You get carbon dioxide and water. And if there's not quite enough oxygen to burn everything, you get a little bit of just carbon left over, which is ashes. So most of the burning you do actually just goes away as carbon dioxide and water. This is like why when people talk about climate change, this is why we're pumping so much carbon dioxide into the environment, is because anytime we burn anything, we're releasing carbon dioxide. So let's talk about balancing, what that is and why we need to do it. So when we deal with balancing equations, we can't end up with any more or less atoms than we started with. We only get what we get. So here's a pretty basic one. Let's say we took hydrogen gas and we combined it with oxygen. This is going to give us water. So this is like a synthesis reaction. So let's count the atoms over here. We have 2 hydrogen atoms because H2 means 2 hydrogens. 2 oxygen atoms because O2 means 2. So 2 hydrogen, 2 oxygen. What do we end up with? Well, we end up with 2 hydrogen atoms, but only 1 oxygen. This isn't good because we can't just lose an oxygen. If we look at this, say, as a little drawing of what the hydrogen molecule looks like, this is what the oxygen molecule would look like, and this is what the water molecule would look like. It doesn't really add up because, where did this go? I can see how this combines with that, and these guys combine to give me this thing. But what about the extra oxygen? Well, we need to account for that. And this is where balancing comes in. Originally, how we wrote it didn't work because we had 2 hydrogens, 2 oxygens, but only ended up with 1 oxygen. And you've probably seen in chemical reactions these numbers in front. These numbers in front are called coefficients. And they're basically how we balance chemical equations. So if we write it like this, so what we can do is write it like this. We have 2 hydrogens, but multiplied by 2. So we have 2 of these molecules. So that's what this 2 represents. The H2 represents this little guy. 2H2 means you have 2 of them. Plus an O2 gives me 2 H2Os. So what that means is I have 2 H2Os. Now if I count, I can see that I have 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 1, 2. So everything works out. 4 hydrogens on this side, 4 hydrogens on that side, 2 oxygens on this side, 2 oxygens on that side. This is the goal of balancing, is to make everything work out. So how do we figure this out? Like, how do we work with this? Well, first thing we have to do is remember that these coefficients are going to tell us how many molecules we have. If we don't write a coefficient, the implication is that there is 1 there. So we could write a number 1 there, and that would be fine, but we don't usually. So the 1 is kind of like implied. So there's 2 H2s, 1 O2, and 2 H2Os. The key with this coefficient is this multiplies the entire molecule. So if we were to like count atoms on this side, we have 2 hydrogens multiplied by 2 gives us 4 hydrogens, and 1 oxygen multiplied by 2 gives us 1 oxygen. The whole purpose, again, is we want to have an equal number of atoms on each side. So let's talk about this balancing example. So this reaction, again, we talked about this before, right? We have copper. It's going to be a single displacement, and you have silver nitrate. This is going to result in silver all by itself and copper combined with nitrate to make copper nitrate. There's a lot of ways to do this. Like people have their own strategies when they balance. I think when we look at balancing, the best way to look at it is kind of how you would think about doing like a crossword puzzle or doing like a Sudoku or something like that. Yeah, so it's kind of like a puzzle, right? Because like, I mean, I'll balance it one way, but other people can balance it kind of whatever way they want. I mean, as long as the numbers work out in the end, you kind of have to fiddle with it. So like even really experienced chemists can't just like look at this equation and just be like, aha, I'll just balance it. You have to like kind of figure it out and try a few things, and don't be afraid to like, scratch things out and try again. So I'm going to walk you through balancing. And then if you have questions, obviously ask or email. But it is something that you kind of have to just like work through a bit. There's a bit of fiddling with it. So here's how I do it. And to me, this method seems to work pretty well. And it's pretty straightforward. So first thing, you write down the equation. So that's there. Now, I always draw a line kind of separating both halves. So I just take my pencil and I just kind of draw a line. And the reason I draw the line is to sort of remind me that there's like this side of the equation and that side of the equation. And they have to be the same. So next thing I do is I write down the elements. Copper, write down copper. Silver, write down silver. Nitrogen, oxygen. And then I write the same element in the same spot on the other side. So copper here, copper there, silver here, silver there, nitrogen, nitrogen, oxygen, oxygen. The reason I write them so they line up is because it's way easier to compare. The next thing I do is count. So there's 1 copper, so I write 1. 1 silver, like there's no number next to it, so I know that means there's 1. There's 1 nitrogen, so that's good. There's 3 oxygens, so I put that there. So far, so good. This side, also 1 copper, also 1 silver. This is NO3, but we look in here and see how there's a 2 there. That means everything in there is multiplied by 2. So instead I have 2 nitrogens and 6 oxygen. Now, I ask myself, are these balanced? And the way it would be balanced is if these numbers are all the same. They're not all the same. These 2 are fine, but these 2 are not the same. So that means I've got some work to do. So let's see what we do next. So what I do now is I choose an atom that I want to fix. And I use a coefficient to change the amount. So the important thing here is to not worry too much and not think like too far ahead. Because if you think too far ahead, you're going to get yourself all tangled up. So the best thing to do is just pick something you want to fix or something you want to make match up, and then just deal with it from there. So in this case, I've decided I want to fix nitrogen. I have 2 nitrogens on this side, so I want to like match them. So the way I'm going to match them is by writing a 2 in front of the silver nitrate, because that's going to let me get 2 nitrogens, because I'm going to multiply this whole thing by 2. So I do that. And it gives me my 2 nitrogens. That part's good. It also gives me 2 silvers, which is not as good, but I'm not going to worry about that. And it gives me 6 oxygens, which is awesome. So now I've got like most things matched, but I've kind of got my silver not. So now I got to fix silver. And what's going to always happen is by fixing one thing, you're going to probably mess something else up. So I fixed the nitrogens, but it like messed up the silvers. That's normal. Don't worry about it. So now silver is the only thing I needed to fix. So I had 2 on this side and only 1 on this side. But silver is all by itself, so if I just put a 2 there, now I have 2 silvers. So copper matches copper, silver matches silver, nitrogen matches nitrogen, and oxygen matches oxygen. There's an equal number of both sides, so now I'm done because it's balanced. It can seem a bit difficult, but it really isn't too bad. The key is not to think too far ahead. Just try to balance as you go. Fix one side, then fix the other, and kind of keep working at it until you're done. If you need any additional examples, if you have questions, if you're not sure if you're doing it right, just please send me an email, or even better, maybe post in the discussion forum, and I'll help you through it as best I can. Balancing is one of those things that's quite important in chemistry. You do it like all the time. And it is a skill that I think is one of those ones that it's a little like shaky at first, but then once you get it, I don't know, I actually find it kind of fun really at the end of it all. So good luck with that. Please let me know if there's any way I can help you. Thanks.